Just taking a while to start recording. There we go. So for this lesson, we're going to be looking at graphing some transformations. And we've done tons of transformation stuff already, so hopefully this is pretty straightforward. But we're going to be graphing transformations of our periodic functions, in particular our sine functions and our cosine functions. So just as a reminder what everything does, our A is responsible for our vertical stretch, vertical compression, and our reflection in the x-axis, exact same as before. Our K is responsible for our horizontal stretch or compression and a reflection in the y-axis. So again, nothing changes there. Same with D is responsible for our phase shift. The only thing that has changed here is the terminology of a phase shift versus a horizontal shift or horizontal translation. And I'll get to that in a moment and show you how that works. And finally, we have our C, which is still our vertical shift. So that one actually doesn't change at all. Even the terminology stays the same. So yeah, Ethan, you can turn your mic off and speak, or you can type your question. So it can end. I can restrict my domain so that it's only a piece of a periodic function. But the idea is that it will continue on forever if I hadn't restricted the domain like that. So that's the idea. Okay, so here is how, oh, one more question. I'll wait a moment until you finish typing your question before I continue. For our Desmos project, do we have to include 5 functions that we've learned? Yes. So make sure that you have a mix of them. So at some point, you have to make sure that you include 5 different lines, 5 different parabolas, 5 different root functions, 5 different inverse functions, 5 different exponentials, 5 different ones of these that we're about to do. So just make sure that you have a really mixed bag of all of them. Okay, so let's quickly recall our parent, oh sorry, I'll back up a little bit. So to graph our functions, we always use 5 key points. So make sure you have 5 points on each graph, and those are the 5 points that we're going to move. And then this is the order we perform our transformations in. We always stretch and compress and reflect. Then we're going to translate it. So we'll move it side to side with a phase shift, or we'll move it up and down. So let's recall our parent functions here because these are new. So first is our sine. And if you ever forget where they are, you can always plug these into your calculator. So sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is -1, and then sine 360 is 0. So if you plug these into your calculator, you'll actually get these values if you're struggling to remember the parent functions. And then I connect them in a nice little curve or a wave here, like that. So that's our first parent function, sine x. Next is cosine x. So if I do cosine of 0, it's 1. Cosine of 90 is 0. Cosine of 180 is -1. Cosine of 270 is 0. And cosine of 360 is 1 again. So I'm just going to connect those like that. So those are our parent functions. And before I transform anything, those will be the parent functions that we draw first, and those will be the points that we will be moving around. We actually move them around exactly the same as we've been doing all our transformations up to this point. So I'm very hopeful that everybody will find this very straightforward and simple. So we're going to do a few examples together. So what you'll have to do is you'll have to first state the transformations, the usual. Then we'll graph one cycle of each transformed function. For these types of questions, when I ask you to graph, I will be very clear of how much I want you to graph of it in order to get full marks, because these could go on forever and ever and ever. But I do need to see 5 clear points. So typically at a minimum, we always graph one cycle. However, I could ask you for more or less on a test, but I would be very clear about that. Then we'll state the key features of the transformed function, our amplitude, axis, period, phase shift, and I'll go over how to do that as well. So let's start with our first example here. So the first thing we have is our A value here. Then we don't have a K, but we do have a D value here and C. So we're approaching this exactly like we did all our parent functions in Unit 1, exactly like we did with our quadratics in Unit 3, exactly like we did with our exponentials in Unit 4. Same deal, exactly the same. So it might sound repetitive, but I really want to make sure that we all understand what's going on. So first is our A. What is our A responsible for? Because A is negative, we have a reflection in the x-axis. Then, because A is 1/2, we have a vertical compression of 1/2. Then we have our D value, and for D, that would be our phase shift, what we used to call a horizontal shift. So in this case, I'm going to say phase shift 135 degrees, and because it's negative, we're going to the right. You can also say translation or shift. I would give you the marks, but just so you can see that for consistency, we'll use that terminology. And finally, we have our C, which is a vertical shift 1 unit up. So that one hasn't changed at all. It's exactly the same. So let's get to drawing this thing. So we're going to start by graphing our parent function. And because of the sign here in the equation, our parent function is sine. So let's start by graphing sine. So we'll have 1, 2, -1, -2. No, Jansen, I wouldn't get rid of any marks if you did that. I just want to make sure that when you go to do this in grade 12 math, that you know exactly what the words mean. So let's graph our parent function. And the more you do this, you'll get used to it and you'll know how to graph this right away. There we go, like that. So my purple one is our parent function, y equals sine x. Next, let's address the reflection. You can do the reflection first or the stretch or compression rather, it doesn't really matter. There we go. So I'm just flipping this thing over the x-axis like this. There we go. Now we will account for the compression. So it's a vertical compression. So I multiply all of my y's by 1/2. So all of my y's get multiplied by 1/2, which isn't too bad here because all of my y's are either 0, 1, or -1. So it makes it nice and easy to graph those. So So that would be y equals negative 1/2 sine x. Next, we're going to do our phase shift 135 degrees to the right. So we're going to move everything 135 degrees to the right. So we'll start with my first point on the far left, move it 135 degrees. Then we'll do the same with my second point. Move it 135 degrees. Oops, I moved it a little too far, sorry. There we go. And our third point, our fourth point, and our fifth point. There we go. And now I just connect those in a nice line. So my orange line is y equals negative 1/2 sine x minus 135 degrees. Finally, the last one that we always deal with is our c value. So now we're going to take all of those points on my orange line and move them all up 1. There we go. So the blue line is my final answer, which is y equals negative 1/2 sine x minus 135 degrees plus 1. So same thing that we've always done, just a different parent function, that's all. So now let's look at some of the key features. So the first one is my amplitude, and my amplitude goes from my axis, which I'm just going to draw here, and let's highlight that in yellow so you can see my axis here. My amplitude is measured from my axis, so it's this amount right here. So in this case, my amplitude is just 1. Oh, sorry, it is 1/2. Next is my axis, so that dashed line I drew with the yellow highlighter on top is at y equals 1. So that would be my axis of the curve. Then my phase shift. So phase shift is the same as my horizontal shift. It's just with periodic functions. That's the terminology we use. So in this case, we went right 135 degrees. And then the period is how long it takes for our graph to complete one full cycle. So we start at 135 and we end over here. So the whole thing is still 360 degrees. We haven't changed anything. I moved it 2 units up. Oh, each one of these is, I went up by halves. So I only moved it 1 unit up because of my scale. But if you do your scale differently, your graph might look a little bit different than mine, which is okay. Okay, any questions before we move on to the next one? We're okay so far? Hopefully you're feeling like you're grasping this pretty quickly because we've done so many transformation things. Yeah, Tur, do you want to type your question or turn off your mic and speak? So from in here, just like when we have our other d value, that's telling me how far I'm moving left and right. Because it's negative in the equation, I'm moving to the right and I'm moving 135 degrees. So same idea as before with our moving left and right, just now it has degrees because our x value has, our x's have degrees on the bottom, or on our x-axis. All right, let's try another one. Stop me if you have any questions. So our next one is y equals cosine of negative 2x minus 2. So let's first address our transformations. So we don't have an a value, so we don't need to worry about it. We do have a k value this time here of negative 2. And we do have a little c value on the end here. So let's first start by writing out what these things do. So my k value is negative, so I'll have a reflection in the y-axis, like that. Now, because my k value is 2, I would have a horizontal compression of 1/2. So remember, with my k's, I always do 1 over k. And finally, my little c value is a vertical shift 2 units down. So that hasn't changed either from our previous transformations. So similar to what we did before, let's draw our parent function. I just want to zoom in just a bit, but it's kind of all or nothing right now. I don't know why. There we go. Okay, so let's start with our parent function. So because it says cosine up here, we're going to draw our cosine curve as our parent function. So we'll start 1, 2, 3, and -1, -2, -3. So this time I am going up by ones, just to point that out so that everybody knows what's going on here. So for our cosine of 0 is 1, cosine of 90 is 0, cosine of 180 is -1, cosine of 270 is 0, and cosine of 360 is 1. So our curve is going to look like this. Oops. I'm so bad at drawing cosine curves. They always look really funny when I draw them. I don't know why. Okay, so I'm just going to quickly label this. So that's our parent function. Yeah, Dimitri, you can type your question or turn off your mic and speak, whatever you prefer. So the next one I'm going to do is I can do my compression or my y-axis. It doesn't really matter. I think I'm going to do my, so Dimitri's question is, does our parent function vary on the graph that's given? So for all of these questions, we only have 2 parent functions, and they're either cosine or sine. So from above here, I have my 2 parent functions. So these are the ones that you need to know, sine x and cosine x. So as long as you know those 2, those will be your 2 starting ones. Alrighty. So now I'm going to do my, oh, so it doesn't change? No, those will be our 2 parent functions no matter what for all of these. Okay, so I'm going to start with my horizontal compression. So that means that I squish all of my x's down. So I'm going to multiply each of my x's by 1/2. So that one will stay. Oops. That one will stay. That one will get switched by 1/2. There we go. So it's going to look like this. So same shape, I just squished it. So now I'm going to label that, and then I'll do my reflection in the y-axis. Oops, that's just cosine 2x, like this. And now let's reflect it in the y-axis. So I'm going to have one there, one here. There we go. So I'll label that one y equals cosine of negative 2x, like that. And now I do my vertical shift 2 units down. Yeah, Dustin, you can type your question. So each of these dots is going to get shifted 2 units down, like this. So that one would be y equals cosine negative 2x minus 2. Any other questions before Dustin's typing his, but if you have any other questions before we get into our amplitude and period and phase shift, all that stuff. Okay, so while you're typing that, I'm just going, so Dustin, you are actually getting to where we will be going with this tomorrow. So sine and cosine are very much related in terms of a phase shift. So we will be addressing that tomorrow and writing sines as cosines and stuff like that. So we will get there. Good question. Okay, so let's figure out our amplitude. So again, on my little blue graph, I'm going to just draw out my axis so I can really understand where what my amplitude is. So there's my axis. So my amplitude is this space in between my minimum and my axis, which in this case is just 1, like that. My axis is that yellow highlighted line, which is at y equals negative 2. You might already be noticing some patterns between our equations and our key features here too, which is awesome. The period here, now this has been squished. So how long does it take to complete one cycle now? It only takes 180 degrees instead of 360. Yeah, Tirth, you can raise your hand. So from here to here, it only takes 180 degrees to complete one full cycle before we start again. Yeah, we will. We can practice writing. It's not on the worksheet, but we can practice writing domain and range for these, sure. Oh, you can literally just type it in. You can type in SIN and it will understand that that's what it is. Good question. Okay, so now is our phase shift. So although I don't have a phase shift in my question here, if I look here, I do have a little bit of a phase shift just with that one little chunk because it has moved it over here. So if I were going to continue this forever, I wouldn't really notice my phase shift, but because I'm only looking at this one little chunk, I do have a phase shift, right? So in this case, we've moved our graph over 180 degrees. Oops. To the left. So because that is our period, I won't really feel it if I continued my graph forever because I just shifted over one cycle basically, but we do see it when we only have one chunk. So that's why it is important to write it and address that it does move. Okay, and we can write the domain and range for this. That's not a bad idea. So my domain, there's nothing stopping my x's anywhere. So all of the x's work for my domain. And for my range, oops, all of my y values are squished between -1 and -3. So y is an element of real numbers such that -3 is less than or equal to y, which is less than or equal to -1. Okay, we have one more example and then there is lots of time for homework. So my phase shift is 180. So you might see some places that don't include this phase shift, because if I were to continue it on forever, it would just keep moving in the same direction. So after I compressed it, this is where it lived. Then when I flipped it in the y-axis, I moved it over here, which took, actually I'll do it like this, which took this point and shifted it basically over here. So if I look at the picture, it's like I picked it up, moved it over 180, put it back down. So sometimes the K value can appear as a phase shift on my graph, even though I just flipped it over there. Yeah. Okay, one more example, and then you'll have some time to practice these. Okay, so sorry, I don't know why on my copy that got squished up there, but that's okay. So our last equation is y equals 3 sine 1/2 times x plus 90. So let's start by addressing our transformations. So we do have an a value, we also have a k value, and we have a d value. So again, notice here how my k value has been factored out of that bracket. Just like before, if it's not already factored out of the bracket, please make sure that you factor it out of the bracket so you get the right d value and everything is correct in your equation. All right, let's go through some transformations. So a is positive, so we don't need to worry about any sort of reflection in the x-axis, but we do have a vertical stretch by 3 because of our a value being 3. Next, because we have a k value of 1/2, we have a horizontal stretch by 2. So no reflection in the y-axis either. And finally, we're going to have a phase shift 90 degrees left this time. So now that we have all of those, yeah, Dimitri, do you want to type your question? So when we are looking at K, if K is between, Ethan, while I'm talking about this, you can type your question. Because K is between 0 and 1, we know that it's a stretch. And then here we always do 1 over K. So in this case, we have 1 over 1/2, which is equal to 2. So that's where that comes from. So remember that about our Ks. It's always 1 over K, no matter what. So on a quiz, you don't need to draw every single translation or a transformation. But if, for example, this one only has 3, so I'd like you to draw 3. There's one at the top that had a few more than that, that's fine. But for each letter, I want you to draw a transformation. So you need to draw 1 for A, 1 for K, 1 for D. If your A has a reflection and a stretch, you can put that all into 1. But because I have 3 values, I want to see 3 different transformations. So up here, because I had 2, I want to have 2 transformations. So you could do the 2 pink ones in one go. And up here, because I have 1, 2, 3, I want to see 3 transformations, even though the A is doing 2 things. So please make sure you're showing them all. Especially if something goes wrong, then I can give you part marks, which is really beneficial. All right, so let's start by drawing our parent function, which in this case is sine, because we have sine in the equation. So I'm just going to label my axes. And I'm just going to draw my parent function for sine. And the more we draw this, you're going to get more and more used to it. There we go. There's our parent function for sine. Next, let's do our vertical stretch. So for our vertical stretch, we multiply all of our y's by 3. There we go. So now we're going to have this really stretched sine curve like that. That looks really stretched up and then brought down. Next, we have our horizontal stretch by 2. So that means that I multiply all of my x's by 2. So this one here will go to 180. This one here will go to 360. And my next one, 270. Times 2 is 540. So this one will go to 540. And then my last one will go to 720. So here's my horizontal stretch like that. Once I finish this, Dimitri, I'll get to your off-topic question. So I saw what you typed. Sine 1/2 x. There we go. And now let's do our phase shift. So we're moving everything 90 degrees to the left. So for 90 degrees, 90 degrees, over 90, over 90, over 90. There we go. So that would be our last one. There we go. So that would be our final answer. And now let's write out our key features. So my amplitude, again, I'm going to find my axis, which in this case is actually just the x-axis because we didn't move it up or down. So it's just right here. So my amplitude is how far I move, how much space is in between my axis and my maximum or minimum. So in this case, my amplitude is 3. Then my axis is that highlighted line, which is y equals 0. The period, how long it takes to complete one full cycle. We start at -90 and go to 630. So our period is going to be 720. And finally, my phase shift, I moved it 90 degrees to the left. And finally, let's practice doing our domain and range. So there's nothing stopping my x's. And for my range, all of my x's are all of my y's are in between 3 and -3. Afshal, do you want to type your question? There we go. So that is our final answer. If you have any questions, feel free to type them now so I can address all of those. If you are done and you feel like you got it and you're ready to go for homework, you can absolutely sign off. I'm just going to answer some questions for everybody.